Hey everybody, welcome back to Faraday Research, and I've just been dabbling with this step-down transformer. It's kind of a continuation of what I did yesterday. So my setup, I added the two 15 kVA ceramic capacitors, and I went back to the single spark gap. So you got the high voltage coming in, goes through the capacitors, goes to the toroid. So I reduced the amount of windings. I changed it to about 70 windings, 22 gauge wire. And then I got a thicker cable and hooked that up to my full wave bridge rectifier. Now, if you remember with the pulse motor, I was creating pulse DC, so I was able to create voltage to light up this. This one's a 5.5 watt LED bulb at 120 volts, 60 hertz. It'll light up. The draw is about 5.5 watts. So I got a weird phenomenon because what I did was basically what I've done is make a solid state version of a pulse motor. So I'm going to show whatever voltage shows up here, say 5 volts, that means it's about 5,000 volts. And the amperage is about the same. So whatever the amperage is, that's what the amperage is. So I basically made a solid state version of a pulse motor. That's what I've come up with. So I got about, I think there's about eight windings of the thicker wire. Actually, not even 1, 2, 3, 4, about 6 windings of the thicker wire on top. That's the secondary. So it's going basically from 5,000 volts down to a pulse DC, but I'm getting a really weird reading. I'm not registering an AC current, I'm registering a DC current, but you're going to see in a second, it's going to be very low. It's going to be like 3 volts, which is totally boggled my mind. I know for a fact I was just to barely get this light lit up with my pulse motor. I needed 160 volts pulsed in order to get that bulb going. Now this one's going to light up twice as bright as it did with the pulse motor, and it's going to take about half the power input. So there's a huge gain using the Don Smith generator, basically simulate a solid state version of the pulse motor. So I'm going to show you right now how it looks. So I'm going to start at 7 just to get it going. Okay, I'm going to drop it down. Okay, let's do 6. So 6.5, so it's about 6,500 volts at 320 milliamps. Okay, now look at the light. All right, now look at the meter. It's showing 1.44 volts. Now, how the heck is that possible? And I can't get this light, the 5.5 watt, lit up with my pulse motor doing 160 volt pulses and get it this bright. I can't do that with my pulse motor, but I can with this. So my first question mark is, why am I only registering 4.5 volts, or sorry, 1.5 volts on my meter? That's the voltage I'm actually registering from the bulb. So that value there has got me really confused. Maybe 140 volts, okay, I would believe that, but why is it only registering 1.47, 1.5 volts? That's impossible. So obviously there's some wavelength, because I got it hooked up to the full wave bridge, so it is coming off as a pulsed DC. Spark gap's going, you can see the spark gap, and it's lighting up this bulb like no problem, like actually really good. Actually, in a second I'm going to light up this 11 watt CFL bulb. It'll take a lot more power to do it, but the fact is I can actually light it up. So I'm going to show that after. But so anyways, these values here are really confusing me. Only 1.5 volts, 1.4 volts, and it's like completely lit up. That's just like boggling my mind. Either something's wrong with my meter, or I don't know. There's some weird phenomenon with, because I figure I'm pulsing with the spark gap. I'm pulsing at, it's hard to say, maybe 120 hertz, maybe. I don't know. These values I'm getting are, I don't know. It's kind of confusing me right now. If anybody has any comments, please leave it below, because I'm just kind of like really confused right now. So I'm trying to figure out how is this possible to only be registering 1.5 volts, and this bulb is like lit up like big time, like way more intense than my pulse motor would do. And I'm only using 6.5 volts at 350 milliamps. So I'm doing it with half the power input, which is quite impressive. But I know the 6.5 volts is actually about 6,400 volts at 350 milliamps coming out of the Don Smith. I'm pulsing it, putting it through the step-down transformer, going through the full bridge rectifier, and then it's lighting this bulb up like, like a light show. Like, it's kind of confusing me. But anyways, if anybody has any bright ideas, please leave it below, because I'm like totally confused with this. I'm going to show you the 11 watt bulb. It's a CFL bulb, so I'll just make sure it's discharged before I touch anything, because I don't want to get fried. Okay, put that one down. This one's 11 watts. I'll even show you the box to let you know. So it's supposed to simulate 40 watts, but the actual wattage is 11 watts. Okay, so if I were to put this on my pulse motor right now, there's no chance in hell that I could light up this bulb. No way. Not by a long shot. So let's screw this guy in here. Alright, let's get it going. I'm going to have to crank it for the first second to get it running. Okay, that's at 8,000 volts, and I'm lighting up 11 watts. And then again, it's only showing 1.5 volts going into the bulb. How is that possible? So where is this energy coming from to light up 11 watts and only 1.3 watt or 1.3 volts, 1.5 volts is going into it? How is this possible? Like, where is this power coming from? Why isn't it being registered? I don't know. If anybody has any ideas, please tell me, because I have no idea. I'll even drop it down. I'm going to drop it down to 6,000 volts. It's still going. It's blinking like it's a very, very fast blink. And look at the voltage that my DC thing is showing. It's showing a steady 1.17 volts. How is that possible? See? I got it about 6,700 volts at 350 milliamps. See the spark? It's actually going a lot faster. Like on the video, it's showing like it's just like a blinking light, but it's actually pulsating a lot faster than what you can see it on the video. So yeah, this is really kind of confused me. So yeah, but irregardless, the step down from 6,700 volts at 350 milliamps going through my step down transformer, my homemade one, is working. And when I put it into the full wave bridge rectifier, I can get a true DC pulse out of it. That's exactly what this is. So in order to get something like this lit up 11 watts when the other one is only 5.5, I must be pulsing at maybe 200 volts or better, maybe 300 volts, but my meter's not picking it up. It's saying I'm only putting in 1.1 volts. So I don't know. It's kind of really confused me. Actually, I'd like to try incandescent bulb. I don't know if that would actually work. Here, let me see. maybe I'll do that in the next video. But anyways, you see what I'm doing. Definitely improvements. I can definitely turn this motor, but because the nature of the pulsing, it's drawing a lot of amps. When you put it through a motor, it seems to really draw a lot of power. That's where the amps get drawn, because this is an induction type motor, right? You're inducing the current in the windings, so there is a big draw of power. So this thing was, I had to really crank it up in order to get the motor going, because it was just drawing so much amperage off the actual Don Smith system. So it either I'm missing something, or what I have to do is take these windings, go to like a 36 gauge wire, and instead of doing like 75, put like 300 windings, because the gauge of the wire is a lot smaller. It's going to draw a lot less amperage, but because I'll put 300 windings on it, it's going to create more of a field. And if I can capture a bigger field, it'll induce the secondary windings, and I might get a better output. So I might have to totally redo this transformer and put the really, really thin 36 gauge wire on it. And maybe that might be the answer to my troubles with getting enough power into a motor like this, or even bigger. So obviously, I'm learning here as I go, but I did make some grounds, and I decided, well, let's try other stuff. Let's try lighting up light bulbs using a pulse, using a DC current. So yeah, so instead of doing it in the monopolar way, I'm doing it in the Hertzian way, right? It's a totally different animal than what the Tesla is. In the Tesla, I can light up 30-watt light bulb, fluorescent bulbs like nothing. So you could see how the Tesla system would have been a way better system to go with than the Hertzian system. This one's very wasteful, and it's showing me that right now. But when it comes to lighting up these bulbs in a pulse DC, I'm getting a lot more gains in the power, but not showing me on the meter. Like it's really weird. So anyways, if you like the video, give me a thumbs up. Don't forget, in the bottom corner, subscribe. Don't forget, I also have my Patreon page. Help me out, fund my work. And well, keep it going, because this project's nowhere near complete. But I'm gaining some really good information and feedback from you guys. So keep it up, and we'll see everybody soon.